And yes, can you believe this? We are not just going live really soon. We are live right now. How do I turn this off? This banner like this. Yeah. Hello, everyone. Welcome to our next chapter of Software Architecture Global Summit. And yeah, today is something interesting waiting for you because we have um, three really great sessions coming up about AI, of course, about practical AI implementation in our architectures, in our workflows, pipelines, and everywhere. Well, I'm not bringing you CloudBot or Moldbot or OpenClaw or whoever they are now, but I will show you someone today who is even better. The project that saves uh, at least I didn't measure actually that, but they say they save 50 to 70% on tokens, which is crucial for me because I burned that oil a lot. I mean a lot because in Geekly AI Labs we were doing lots of AI tools, AI stuff. So um, that's crucial for me. And I'm sure you are using AI more and more and compressing, smart compressing, modern compressing, all these token optimization strategies and stuff. I think it's even better for us as developers than those desktop automation tools, which are quite fresh and not that trustworthy yet. Anyway, um, I see on my backstage one of our speakers. Let me try to pull him up here and say, hello, what's up? Can you connect with camera and say hello to our audience, or it's not, or you're not ready? Three, two, one. Probably not ready. Okay, then. Oh, yeah. Hello, hello, hello.
Hey,
And
hello.
how are you today?
Doing good. Having a bit of an urgent issue at the work, so trying to resolve those items.
Yeah, of course, of course. Thank you
Yep.
for coming and tell us where you now and why are you actually sharing about this topic you do.
Okay. So first of all, I'm Vatsal. I work as a cloud engineer at CVS Health. My work, though title says cloud, but it's more involvement towards AI and data that we are trying to approach in the healthcare industry. So, with all this AI and all the stuff, my journey started probably 4 years back when I was doing the bachelor's degree. And I was good at mathematics, so I was getting some guidance from one of my mathematical professors. He was trying to get into this field of data science at that time. So, he referred me a couple of online courses, mainly the machine learning course from Andrew Ng on Coursera. So, that was the first day, our first moment of mine when I started and kick off the journey in machine learning. So from that time, this tile gain was introduced after a couple of years, which was generative network basically, which can generate multiple faces which people do not access at a high quality. So that was the time we took us. I personally, me and my friend took a step into generative networks, and we thought, okay, this is really cool. We get into the field, we created multiple projects, and we liked a lot. But at the same time, obviously, since it was a generative field, stuff which is was generating and controllable, even like, okay, I would like to have this much of a long beard, this much of a darker eye, and all those stuff. So we in general, like, thought came to our mind, okay, there has to be some sort of a governance around it, like how people can manage, how people can stay aware of it, how we can track of it, all those kind of and stuff. And then I joined CVS, luckily as a part of governance team only. So I got a chance to be part of governance work, and that's where all this journey came. And I, worked on multiple projects, all related to governance only, and thought of sharing this knowledge with world, because okay, these are the ways you can efficiently do this process. We already implemented it, we have seen that it is working at an enterprise scale. Just adapt it and play with it. I mean, come up with something new with that, so you don't have to start from zero. So that was the idea, to share this knowledge. I think you are muted or something, but I cannot hear you.
Yes, sorry
Oh,
about that. And yeah, thank you very much for sharing. Now, I feel you have passion to all this governance, guardrails, and everything. And as you probably guessed already, Vatsal Bhavani will be speaking about beyond the hype practical AI governance for enterprises scaling generative AI.
yes, sir.
So yeah, we're stepping in a crazy time, and this guard railing, and
Yeah.
uh, protecting us from Skynet is actually super important. Thank you very much for coming to say hello. Now we're going to backstage, and we are playing our sessions, and then come back and having fun and answer questions. And you know how it works, right?
Yeah, definitely.
Okay,
Thank you.
okay, ladies and gentlemen, Vatsal Malani and his great presentation uh, on on the practical AI governance for enterprises scaling generative AI. Let's go.
Hello, everyone. My name is Vatsal Mawani, and welcome to the Architecture Summit. Today, I'm going to talk about beyond the hype, the practical AI governance. It is more about the trust layer that has to be there in the enterprise generative AI, or any generative AI, I would say. So, let us just start with the next phases of it and see how it goes. So, starting with the origin story. So, basically, to explain why this matter, let me share you a quick story of mine, which is basically started with my side hustle. So, in probably like a few months back, me and my friends were just sitting together, and we thought of creating one AI travel engine, or say the thing which we are calling as a travel genie. Basically, we found of doing small trips, and we also have multiple travel cards, right? So we always have this miles option with us, or the travel points with us, which we tend to use to book some hotels or to get some good flight deals and all those stuff. So usually we have to go through this manual process of finding those deals and make the most out of it. So we thought of creating or utilizing these AI agents, so that as per our requirement and as per our available points, it should be able to find some good and the best deal, I would say, which accommodate all the requirements and is the cheapest one. So we initiated the process, and we created some initial product of ours, and we were started using it. In that, we found two major issues. The first one, which we call the $600 weekend. So basically, what happened was that we were just trying, multi-agent scenarios for our thing, and we were parallelly running multiple agents to test out how it is doing and what it is doing. In that one of the tests on the weekend night, we just started the model. Usually it take around 10 minutes or 15 minutes for our whole end-to-end process to be working. So we thought of, okay, let's just kick off the process through multiple scenarios in multiple agents, and we'll just come back and we'll take a look at it. But we forgot it, and on the and the next day early morning, we received an email from the OpenAI saying we reached to our maximum quota, which was around $600 through spread it across multiple agents. But we in like it, the all the agents ran about 8 hours. They basically entered into a recursive loop where they were trying to find the best option for our Tokyo trip, and they were just going through the same process again and again, starting from the beginning and trying to find the best possible flight, and they reached to the maximum limit. So that was the first thing that we faced as an issue. The second one, the second problem that we had was what we are calling it as a Reddit attack. Basically, we were thought of, okay, let us put together some of our close friends and also share the link on the Reddit. But mostly it were our close users only, close friends only. They were doing the beta testing of it, and during that they found that one of the friend who was kind of a nerd, I would say techie nerd, so he were able to crack it up and he was able to ingest some of the prompts, and through which he was able to pull out some of the internal informations, and also he was successfully able to run the terminal commands, Linux terminal commands, which is kind of scary a lot, because if they can run the terminal commands, that means they can literally handle our servers. So that was a really bad one that we had to fix it quite urgently. So the solution that we came up with in our version 2 was what we call this as a trust layer. So basically, this is a centralized piece of a software, a middleware, which sits between our application and the AI model, the backend AI model that we have it. So it handles three critical things: the cost control, obviously, the security policies, and the last one is observability. So let's look at all this one by one so that we can go over it. So the first pillar is cost, which is nothing but we are calling it as a financial governance. So after that $600 weekend, we made quite a lot of changes. We implemented something called semantic caching. This means if user ask like a common question, more of a common question like, okay, visa requirements for the specific country, like a Japan for our trip, right? Then the system remember those answers. And it was not a regular caching; it was more of an intelligent caching, where as per the people's frequency of the questions and scenarios of a question, it will try to do a caching of those kind of questions like visa requirements or some trial kit for some places like hiking or snowboarding or somewhere they usually go to in seasoning areas. So those sort of questions, it will do a caching of it, and then whenever user prompts those kind of questions, they will just pull up the information from those caching layer rather than going to the AI model where the tokens get used, or maybe larger models get used. But in the same phase, even the second idea of our, which we are calling a model abstraction, that made also quite of a change. And overall, we dropped our monthly bills to $45. And to say like, the obviously there weren't that many user, but even with the that user base which we had initially, we were getting around like $300. It seems a huge jump, but it was there because of the model abstraction and caching. We reduce it down drastically, I would say. So talking about this model abstraction, right? This meaning like basically we decouples our application from the specific providers. So that way we can utilize more of the free models that we were getting, or the cheap models that we were getting for initial conversations, or some high level questions that we have to deal with. And when the agent has to go with the detailed planning stage, then at that time they will just go over they will go for the bigger models, or the models which requires a lot of reasoning stuff. So they will go for those models, which is kind of costly, but they will get used a little less compared to for the because of the normal questions getting handled by the lower models. So that helped a lot to save the cost. Now, talking about the second pillar, which is our operational security, or we are calling it as the firewall for logic. So, for that one, basically what we think of it as like, okay, we need to filter our inputs. So before a prompt even enters to our environment and it leaves out of the environment after getting the output generated, it has to go through some of a governance process. So where it should be removing some PII data or PHI data, if there is any like personal health information or personal identity information like SSN or personal name kind of a thing. So those things has to be removed. The second thing which we focused on was the jailbreak defense. Basically, we created a system, internal system, which removes the instructions or instructions from the prompt which says, oh, assume like this, behave like this. Basically, try to change the persona which was already has been assigned. So those sort of an information it will try to remove, those sort of an instruction it will remove from the prompt, and later the fine-tuned prompt will ingest it to the AI model so that we get the more of like a uh, enhanced results, and we can be defense from the jailbreak. So this quite help us because the user who tried to who was able to crack down the earlier version has tried multiple ways, but he wasn't able to run any of the Linux command, or neither even try to. He earlier was able to get some premium features without having those subscriptions available, but this time he wasn't able to get through this, even though he knows some internal stuff, but still he wasn't able to go through the system. So this was kind of a win where we introduced one of the additional layer as of a security, and it worked out well. Now, the next item, the last item, I would say is called data integrity, which is the third pillar of ours. So, in a software application with many users, you have to have a multi-tenancy scare. Basically, you absolutely cannot have a user A seeing the user B's data, because ours will be people will be going through a trip search, multiple travel details, the hotel booking they will be going through, so they should not be able to see each other's information or their credit card related details, like how many points or miles they have, it this sort of in details, right? So the fix was here that identity aware retrieval. Basically, we moved to a setup where each individual search query will strictly have the user ID with it. I know it seems to have a quite obvious thing, but when it comes to this sort of a platform or AI agents building thing, we tend to forget about this. So this identity aware retrieval, where we use the user ID with all individual search queries, will only because of that part, it will only pull up the data for that particular user. No other files will be have no other files will be accessed. So that way, the information will be kept and secured. So that was the three pillars that we have introduced as a part of trust layer. Now, after implementing all this, we obviously have to have some sort of automated evaluation, because so far what we tend to do is manual wipe checks, where individual users just get through the screen and they will just type out some of the questions, some of the scenarios that they have in the mind, and if it works out good, then they'll just say yeah, it is good thing. But that is not scalable for sure, and we cannot. And it's more of a subjective thing, I would say. So what we introduced was a model-based evaluation and a golden set of records. So what does it meaning? Meaning that we use a smart model, like latest advanced model or very depth reasoning models, to create the accuracy of smaller models that we have it. On top of that, we will have this set of golden records, which is quite optimized output that we have gone through manually, probably 100 or 200 records out of it. Right now we have around 300 or 350 records of it, but this will be like a golden set of records which has to gone through the testing for each smallest piece of a code change that we do. Only after that, if it passes, then only it should be going through the productionization of it. So that way we will be doing an automated evaluation in a proper professional manner. Now, uh, to wrap it up, here is our governance checklist. First piece of it is centralize. Funnel all your traffic through an AI gateway, just like an API gateway, so that no rogue API keys floating around here and there. Second, standardization. Enforce your guardrails at the infrastructure level. And the third one is monitoring, which always track your cost and monitor in real time so that you can improve the quality of your product. The last, governance is not a blocker, it is a guardrail that allows you to drive fast. I always keep this quote because that does change a lot of mindset, I would say. So that is all for today. Thank you. Thank you very much.
Yeah, thank you, Vatsal, for this overview. Lots of interesting stuff you implemented, and thank you for all this brief mentioning those cool things. I have to definitely dive in there because for our own applications in Geekly AI Labs, we do really need to, of course, lower our expenses. Even though we funded with credits by AWS and Google and Microsoft, but still they are not, um, it's not a golden rain. So we'll over someday. Yeah. Thank you very much, and for keeping us safe. And on my backstage, I have the good friend of mine. I'd say, hello, Naga. How are you?
Yeah, I'm good, good. How are you?
Doing great. Thank you very much for joining. How are you doing today? I remember you had kind of health issues later,
Y-
latest.
yeah, we were hit by a bad flu, so we're still recovering from it. So that's why I couldn't record the session earlier. So yeah, doing much better compared to last week.
All right. Anyway, thank you for joining. That's why this time we accepted the live presentation because normally we don't do that, but because I know you well, and I'm sure you will be very straight to the point, very practical, and yeah, ladies and gentlemen, today with us Naga Santosh from Microsoft, building agentic AI applications using Docker, MCP Gateway, and Toolkit. Okay, it sounds like Docker's throwing out some cool stuff. The stage is yours, brother. Let's go.
Yeah, I shared my screen, so hope you guys can
Yeah,
see it.
we can see it. We can see it.
Yeah, I'm also on my phone just to make sure that whatever I'm sharing, it's
Yeah,
appropriate.
sure.
Okay, perfect. Yeah. So welcome to this session. Yeah, good morning, good afternoon to everybody watching it live. So I'm going to talk about how to create agentic applications using Docker MCP toolkit. So there is this cool stuff from Docker. So yeah, strong brief introduction about me. So I'm Santosh. I'm currently working as a principal software engineering manager at Microsoft for Azure SQL Server team. Um, I blog at DZone. I'm also a core MVP there, and I also do active mentoring on Editor List. And yeah, I've written three books. So the last book just got released a month ago. This is on vibe coding with GitHub Copilot. Definitely check this out. And if you want to reach out to me, definitely you can reach out to me on LinkedIn. So yeah, so what are we talking in this particular session? So I'm going to discuss about the Docker MCP catalog.
I am sorry. I'm sorry for interrupting you, but the audience asking if we can improve voice a little bit because it doesn't sound like it goes from your headset. Maybe it's unplugged or something like that. Maybe you could check
Uh,
it for us.
Yeah, sure. I'm using mic only. Can you hear me better now or still the
No,
same?
it's the same. Maybe some kind of settings here in StreamYard. Maybe you can open them. Just take a minute and improve because it's quite hard to hear. You can open settings and then audio and make sure it uh, takes the right audio source, if you would.
I changed the settings, so it is still the microphone. There's the microphone headset. Yeah, is it better now or still the same?
Yeah, I guess it's better. I guess it's better now.
Okay, okay. Yeah, sorry about that. I don't know. Like I selected
No
the yeah.
worries, no worries. It's okay. It's okay. You are good now. Yeah,
Okay,
yeah. I guess. Yeah.
perfect.
Just go on. Sorry.
Sure. No worries. Yeah. Thanks for letting me know how it happened. But yeah. Yeah, so in this today's session, so we'll talk about the Docker MCP catalog and Docker MCP gateway, Docker MCP toolkit, and I'll end with some cool demos. So let's talk about generative AI and agentic AI. So in generative AI, like generally you would have, most of you folks have used ChatGPT or other chatbots where the user provide with some prompt and then LLM dissect it and it generates text, image, videos, or code. But in the agentic AI world, right? So you want little more than that, like not just generation of content, but also to act and take some decisions on it. So what we're trying to do here is when we say agentic AI application, so you are providing the LLM with more context, you're providing with memory, and you're also providing with the tools to take some action. So these tools can be let's say you want to interact with GitHub APIs and retrieve some information about your work items or PRs or other stuff. So in order to do that, like today, what we generally do is like we write, tighter integration code in your application where you call GitHub APIs and do the stuff. But with LLM and agentic AI world, what we're trying to do is we want to leverage. There is this concept called MCP, which is Model Context Protocol. What we're trying to do here is provide the context or a way to interact with all the third-party applications or even your legacy APIs that you have in-house. You can bring that into your LLM. So for that, there is this approach called MCP. So I have made a presentation last year when MCP was pretty new. I've given a presentation about MCP. Definitely check it out. It's in detail. So what it does is we can interact with GitHub MCP, and the LLM has now more control about talking to other APIs and other tools, and it can act on your behalf. So that's what we're gonna see in this demo as well. So when we talk about this building agentic applications, right? So there are basically there are just three major challenges that we see. So there's a bit of a learning curve, and then you need to understand about this tool discovery, like where exactly this MCP tools are running, where is the server, and then you also need to think about privacy security. Why? Because there are multiple people, creating this MCP tool. So whether you can trust them or not. So most of the time when you, let's say you're interacting with GitHub MCP, you need to provide your credential information as a path token, or you can also leverage OAuth. So when you're dealing with this thousands of MCP servers which are available online, so I'll show you a GitHub repository where you can see that more than 1,000 MCP servers, and that list is growing. So how do you think about privacy and security, right? So how do you know that MCP server that it's secured and safe enough to be consumed in your code? So that's where these challenges are currently. And Docker realized that okay, there is a good problem at hand, and they decided that they can implement this feature called MCP Gateway and MCP Catalogs. I'll talk more about it. So in agentic applications, we need like three things, right? Basically, your models, LLMs, and then tools, the MCP one, and then your application code. So what happens here is when you're talking about this, building agentic AI as a single agent architecture. So you have this application where you have your model, and then user provides you with the prompt, and they will also provide you with the context. And now the agent has all the information, so it knows which tool to interact with. So if let's say you have three tools, GitHub and Playwright, and then Notion, right? So you integrated that closely in your application. And when you ask a question about, hey, can you pull me all the GitHub repositories that are in my account? Then agent with this context information, it knows and it automatically hits the GitHub MCP server to retrieve the information. So the AI agent has become smarter, and even though you provide multiple tools, it knows which tool to invoke and call that particular API. So that's where the MCP protocol has been going crazy from early last year. So what exactly is MCP like? I'll just give you a very brief overview so that we can jump into the real-time demos. So think about when we move to the standard APIs, right? So APIs are basically how we standardize web applications, and then we have this language server protocols where IDEs like Visual Studios or JetBrains or other IDEs, how it can interact and how it can do code navigation and analysis. So similarly, we have now MCP, which is like I would consider this as like USB C kind of an application where you can easily plug and play different MCP servers. So if you look at this particular diagram, so here what you can see is there is this MCP host. A host can be any any IDEs like Cloud Desktop or Visual Studio Code. And inside that, you have the MCP client running, which is GitHub Copilot, which is running inside the host. And now you are plugging in different MCP servers, like, one for Slack, one for Google, one for, GitHub. And you can plug it in all the MCP servers, and this goes inside the mcp.json file, where you can see the list of all your MCP. And then now within the GitHub Copilot chat window, you can ask different questions. And it automatically knows which MCP server to call in, and then it will provide you with a response. So this is like, a brief architecture where, as I mentioned, there is a Visual Studio with GitHub Copilot client, and then you have multiple MCP servers. Each MCP server has a different responsibility. Like MCP server A is talking to a local database, B is also talking to another local database, and then C it's calling third-party web APIs. So with this architecture now, you are providing LLM with more context, and it knows which particular MCP server it can talk to, and it can get you the response. So yeah, this is with and without a MCP. So if you, let's say you don't have a MCP in place, right? So now you have to write all this integration in different parts of your application. So every time you are interacting with GitHub, so you need to do the same stuff of authenticating and calling GitHub APIs. And if you have like five different applications, in every application you have to rewrite the same logic, or you can create a library and then you can use it. But with MCP, what we are trying to do here is there will be one standard gateway where you can interact with all different MCPs within different applications. So that's what this picture depicts. But there is a difficulties that we are currently seeing with MCP, right? So when MCP got released for the first time, it was like, there was no authentication involved. So anybody can just call. It was not, it was one of the biggest drawback back then. But now there have been a lot of improvements on the MCP side. But we still face this particular difficulties where how do you discover and how do you distribute your MCP server? And when you're trying to install MCP server, it comes with runtime and different libraries, right? So you also need to go through the process of installation and sandboxing. And then there is another problem of credential management. So as I mentioned, in order to use GitHub MCP, you need to give your credentials. You need to either do OAuth or provide PAT token. So all these are current difficulties, and this is where Docker realized that okay, there is a problem at hand. So let's go ahead and implement a solution. So they came up with something called Docker MCP Catalog and MCP Toolkit. So why Docker makes it easy for developers, right? So Docker has been like, a go-to number one solution for your container management. So you can rely on, pushing all the images safely, and it provides you with that, isolation from other applications. So same now with MCP. So they wanted to make sure that, they provide the same, solution where they can containerize this particular MCP so that you don't have to deal with the problem of privacy and safety issues. So it is providing you more simplicity and a secure way of using MCPs in your applications. So what they have done is they have created something called MCP Catalog. So currently there are like 270 plus containerized MCP servers available. So if you go to this link, you can see the list of all MCP servers starting from Playwright, DuckDuckGo, Notion, GitHub, and multiple. So the list is growing, and once this MCP server is hosted on this MCP catalog, you can by default you can consider this to be like safest as well as secure way of using MCP in your application. So in order to use it, they have introduced something called MCP Toolkit, where you can see the list of servers available from the catalog. You can add them, and you can add also to your clients, because at the end of the day, you have this MCP server running, but now you need your client to connect to it. So clients are basically your cloud desktop or Visual Studio Code or Cursor or other applications. And then it also provides a way to OAuth, like a way to provide credential management. So everything has been automatically provided in this one-stop solution, so that in future, if you are switching from Cursor to Visual Studio Code to Cloud Desktop or different application, you don't have to repeat the process. So you just need to add one particular configuration, which is MCP Catalog, and that's it. You don't have to provide details for each and every MCP server. So if you look at the current solutions, right? So if you go to the mcp.json file, you see the list of all the MCP servers that you're adding and you're running. So with this approach, you don't have to do that. You just have to provide only one configuration, which is MCP gateway. And within that, all the servers, whatever you have added into your Docker desktop, it will be available to you automatically. So that is the advantage with MCP um, toolkit and MCP gateway. So this is how you can add different services. So the list can grow, but your YAML file or your configuration file, it still stays the same because you're just adding only MCP gateway. So I'll show you that during the demo. But this is what we are currently trying to do with the agentic AI applications. So now you have this agent application where the user is asking you with some questions like show me all the list of GitHub issues and create a Notion task list. So what it does is now it goes and it talks to LLM, and you also added all these different MCP servers. Like one MCP server is GitHub, another one is Motion, and then you have SQL if you want to write it to SQL database. So the LLM understands this. It reasons what kind of prompt that user has given, and then it goes ahead and it plans the next set of steps, and it will go ahead and invoke the particular MCP server, and it will provide you with the response. So where does the MCP gateway from Docker comes and sits, right? So it comes and sits right here. So now what we are trying to do is instead of providing the JSON configuration file for each and every MCP server, now there is only one configuration which simply say Docker MCP, and inside that you can add multiple servers. So the advantage here is there is only single place where you are configuring all the servers, managing your credentials in a safer way, and then you are consuming it in all your agentic applications. So yeah, this is how the structure will look like. You can include whatever models that you want, and then the MCP gateway, it simply says hardly 4 or 5 lines, and here you can increase your number of servers. Like let's say I added only DuckDuckGo initially, and then I want to add Playwright or GitHub official MCP server. You can just go ahead and add that inside this particular file. So let's look at the demo. Let me switch back to my Docker desktop. So the main prerequisite for this is you need to install Docker desktop. So once you install your Docker desktop, just wait for a second. Yeah. So once you install your Docker desktop, so if you go into the settings, there is this beta features where you have to come and you have to enable this Docker MCP toolkit. So once you enable it, and once you go back, now here you will see the MCP toolkit option available to you. So if you go into the catalog, so this is the same catalog that I mentioned. So when I took that screenshot, it was like 279. Now the list has increased to almost 312. So you can search, basically different different MCP servers that are hosted here. So let's say you want to use GitHub official. I think I already had it on my servers list. So let me just go ahead and delete this. Yeah, so I'll come back here into the catalog. So let's add the GitHub official MCP server. So once you click on the GitHub official MCP server page, right? So here it will show you the MCP information, and it also provides you with the list of all available tools. You can see whether it's coming from the official GitHub team or it's coming from a different person. So you can see all the information here. So this has been added by the Docker MCP team. So you can see the list of all the tool information here. So once you confirm that, okay, this is the server you want to add it. So you come here, you click on add MCP server. And once it adds, you go back to the main page again. So now you can see the list of server. GitHub official MCP server has added. So once you click on it, so here there is an option called configuration. So this is where you provide your credentials. So not all of the MCP servers need some sort of credential or access. So if it doesn't require, then they won't be no credentials required, so that options will be provided here. But for GitHub, since you are making GitHub API call specific to your particular account, so you need to either provide a GitHub access token or OAuth. So I already allowed it. So now I go back. Now I need to add this to my client, right? So client, as I mentioned, you can use all different sorts of clients available, starting from Visual Studio Code to Cloud Desktop, Cursor, Gemini CLI, so anything. So instead of you going and writing the configuration, so let me show my GitHub Visual Studio Code. So if you see the Visual Studio Code today, right? So when you click on this particular button at the bottom of your chat, it will show you the list of all the MCP servers that you have added. And when you click on the edit, it automatically opens this mcp.json file. And here you are showing you are basically adding the list of all MCP servers. So I have added one for Azure MCP server, and then there is DevBox, and then there is MCP Docker. So as you see here, I am not providing any information about the GitHub. So GitHub is automatically within my Docker MCP, and I'm providing the information only about the gateway, right? So it simply knows about the MCP gateway to run, and whatever servers are within the MCP gateway, like all these servers, or automatically now I have access to them in my Visual Studio Code. So that is a major advantage. So your file, your mcp.json file will not grow. So it will just remain as it is if you have only one MCP gateway added to it. So that is an advantage, and there's only one central place to manage all the credentials. So now once this is added, so you can come back here and you can, I already started the chat here. So where I can now invoke my MCP Docker, which is the name I have given here. So let me just say MCP Docker and say pull in the list of repositories from GitHub. Since I already provided information about my GitHub account by using the OAuth, so it now go and talk to the MCP gateway, as you can see here, and then it automatically invokes the GitHub MCP server and pulls back all the list of repositories. As you can see, it is invoking the MCP Docker. So once I click allow, it goes ahead and brings me the list of all repositories. Just a second. Yeah, you can just click on allow in this entire session as well. Session. Yeah, it's bringing in my particular account, which is github.com/saminagawa. This is my URL. So once it gets all the information that it requires, okay. So it already brought in some of the information. Let's just wait for this. Okay. I think it's going in a loop, but yeah, if you just scroll up, so I've already done this once in the Visual Studio Code. So it just goes ahead and brings in all the list of GitHub repositories like this. So this is one thing that I already pre-configured. So let's just go ahead and bring this same thing in the Cloud Desktop. So in Cloud Desktop, I have not connected yet, right? So I'll just go ahead and click on connect from Cloud Desktop, and I launch my Cloud Desktop now. So when I launch my Cloud Desktop, so here, so this particular MCP underscore Docker, which is automatically added. And now I can just ask the same question from a different uh, client as well. So list of data repositories. Okay, so now from a different client, so I didn't change anything. It's just one click of a button, and again, it has all the information as it's talking to the Docker MCP, and it knows which particular MCP server to call. I have the list of all, like what, how many, 7 servers are there, but it still goes ahead and pulls information from GitHub official, because this particular thing is, as I'm asking a question about GitHub repository, so it knows which particular MCP server to interact to, and then it brings me all the list of repositories that I have. So that is an advantage. So now what you can do is basically take this and consume this in any of your application just with one particular click here in the Docker desktop, and you can connect to your client. Or if you want, you can also generate a YAML file that I showed here. If you are consuming that as part of your application, you want to deploy it, you can also specify the MCP gateway details, and you can go ahead and leverage as many servers as you want. So that's an advantage with Docker MCP, and you can build all the agentic applications using Docker. So yeah, that's about my talk. Yeah, back to you, Ed.
Yeah, I'm sorry, man. Thank you for sharing. That's interesting. They are trying to protect us, and that's great.
Yeah,
Um,
the, the
most
main advantage. Yeah, so sorry. The main advantage here is like you'll get the the security that's automatically comes when you make use of Docker. So everybody has been using Docker from the day it was launched back in 2014. So it's the safest way to consume or share your images. And now they are moving more towards AI. So that's how they decided. Okay, now let's introduce this MCP gateway and catalog. Now, as I mentioned, there is this GitHub MCP repository where you can see thousands. So every day, people are releasing their MCP servers. But how can you trust them, right? With Docker, now you can trust them. Now, once it is added to the Docker catalog, so you can totally rely on that particular MCP server. So that is an advantage.
Okay. Thank you very much. And what I see now, most of our sessions now are about security, about protecting, about standardizing. Um, yeah, and recently we had this QA summit. Also, most of our talks are about protection, because, like, hype goes down, real adoption goes and rolls and grows, and yeah, we still need it. Thank you very much, and yeah, we're moving on, and see you in like 25 minutes
Yeah,
then for
sure.
Q&A, if you can. Okay.
Yeah, sure. Yeah, I'll be there. Yeah, thank you.
Cool. All right, and we're moving on. Something was really interesting a few days ago. It's very raw. A few days ago, the friend of mine, Dodges, who works for Netflix, he said, "Hey, Ed, we built something amazing. Hey, come and check it out." And they built Headroom, which is token optimization proxy working on your machine and saving lots of tokens and money, and even making smarter and brighter LLM responses. So we just got online and recorded this session. He had some slides, and we just want to share it with you because it's a mainstream. It's something very, very, very new. And here we go. Yeah, Tajas Koprov with Headroom, speaking about context optimization for LLM, saving 80% costs. of token. Let's go there. Interrupting you. So
No
it's
problem.
it's something for infrastructure for vibe coding. Yeah.
It's not just for vibe coding, it's for anyone that's building agents. It's, you have an app, you want your app to interact with an LLM. This is something that sits in the middle between your app and the LLM. It can be a part of the app layer itself, or it can be a part of the foundational model companies as well. But what it does is essentially, let's say you're using Claude Code or Cursor, and you say, you know what, I want to build a piece of software, and go and do your deep research, and then come back and tell me how to write the code, or write the code for me. A lot of these calls translate into a lot of tokens. You get back a lot of tokens. Now, what this middleware does is it looks at the tokens and it compresses them intelligently. So there are many prompt compressors that compress a prompt, but prompt compressors do not work well with JSONs, for example. If you have a JSON structure, if you try to put it into a prompt compressor, it will just not be a JSON. It will remove the columns. It will not be a proper JSON at the end. Instead, what this middleware does is, or this SDK does is, it looks at the type of data and applies the right type of compression based on the type of data.
Okay.
So for JSON, it uses statistical analysis, where it will look at duplicates and remove the duplicates from the JSONs, but still preserve the JSON structure. It will do the same for code. It will do similar for GitHub repositories. It will do the same for other text. So it is a classification and using different types of compressors depending on different type of data. Now, the net effect of this is you can save up to 40 to 70% of your tokens. And the best part is it is without any accuracy loss, because the concept that we've introduced is reversible compression. So many people just compress the data and throw out the original tokens. We actually keep the original also in the background. So if the LLM cannot find the thing it is looking for in the compressed data, it can fall back to the uncompressed original tokens. That is new, because not many, in fact, none of the competitors or anybody out there does it. The other best part is this is open source. So it works on your laptop. You do not have, everything works on your laptop. There is no API key needed. You just have to run one line of code and it'll work. And it will save you a lot of money, and you can see how much money it is saving you. I'll show you a demo as well here. Now I went beyond that. So there are two aspects I covered beyond just text. One is text is just today. Tomorrow it will be voice. It will be, images and video. So there is a change also done to support images. So what happens is, let's say you upload an image of a room and ask ChatGPT, can you find the color of the television in this room? ChatGPT will take your full image, it in the highest pixelation, it will tokenize it, and then it will answer the question. What we do is, before the thing goes to ChatGPT or any other coding LLM or any other LLM, we will look at the question, we will look at the image, we will reduce the size of the image if you are not asking for something specific. So it is 80% less tokens. But if you're asking for what is the brand of the television, we will not do it, because it is important to send the full size image to know the brand. So we get very intelligent with image as well here. Yesterday I was playing around with voice a little bit as well. So the whole idea is it is multimodal context compression platform. Now the interesting part that I've added here is memory. So let's say you go to Claude Code or some other place and you say, I like dark mode in one of the Claude Code tabs. When you open the new tab, it still starts with having no idea of who you are, what you want, your preferences, user preferences. So memory, there are many companies that do memory. There's MemZero, Letta, many other competitors. What they do is, you are working with an LLM, let's say ChatGPT or OpenAI. They will have another LLM that they own, and they will take your conversation and they'll use this other LLM to extract memory out of it. What we do is, when you're calling the original LLM itself, we will ask it to store and save memory. So you do not have an extra call to any LLM, and you get the benefits of using the original LLM itself. And it's very simple to implement or use memory as well in our system. So Headroom is a context optimization platform that has intelligent compression for agents. The whole idea is it'll cut the cost by 40 to 80% without any information loss. So if you have applications like agents, tools, Claude Code, Cursor, any voice agent as well, you typically talk to LLM providers like Claude, GPT-4. What we do is we intercept your tokens in the middle, and we can reduce it from 50K tokens, let's say, to approximately just 5K tokens and send it to the LLM. There are two advantages of it. One is, of course, the cost part, but the bigger advantage is reduction in hallucinations. There is a study that says that even though token windows or the context windows have increased, only like very small part of it is actually very usable without loss of information. And the way Headroom differentiates itself from anything that is out there is it has where others just compress the data, we have intelligent compression. Depending on the type of data, we can allow different types of compression, like I said. So there is we've implemented something called as a smart crusher, which is statistical compression of JSONs. We have cache, compress, retrieve. So what that means is CCR. It will cache the data, the original tokens, 50K tokens. It will compress it and return 5K tokens. And if the LLM is not able to find what it needs in these tokens, it can retrieve the cache. So it is reversible caching in some, or reversible compression in some ways. What we also allow folks to use Headroom for is cache aligner. What that means is in Claude and in GPT, when you send the same prompt again and again, they have something called as prefix caching. They will cache the prompt and they will not charge you a lot of money. But let's say you have a prompt in which you've just changed the date or a very small part, let's say the UUID in the prompt. You have lost the benefits of caching. What we do in Headroom is we look at the prompt and we eliminate or we take out the dynamic parts from a prompt and send them separately. What this allows is a bigger cache hit on your prompt. And so you can save even more money. Just one install, that is pip install, and it just works. Let me show a simple demo. So this is where, I'm running Headroom with Claude Code. I run one command called Headroom proxy after doing a pip install. It starts. Now in the other window, when I start Claude, all I have to do is change the Anthropic base URL to point to where the proxy is running. Everything runs on localhost, so you do not have any place that you're sending the data to. And you can run Claude. So you will now see that I will ask a question that we are in a repository. Can you use multiple subagents and investigate this project and give me your take on what is truly novel and valuable? So this means that I'm doing some deep research, and this will farm out multiple subagents here in Claude Code. Everyone knows this, how this works. The interesting part is here. So now in the Headroom proxy itself, you will see examples like this, where the pipeline completed and you were able to see 84% reduction in tokens. Note that the original code, so this is still happening. It's still searching. It's still doing things. This is interesting. So in the stats, like if you do /stats, you will notice that you've spent $4 in this session, but you've also saved $3. So ideally you would have spent $7, $7.7. You ended up just spending $4.4 because our proxy saved you like 80% of the costs. You will also notice the savings percentage here. It's 75% savings. When the session completes fully, you will notice this. So when the session fully completed, it spent around $8, but you saved $4 out of it. So this is an example of how Headroom can help you save costs, and the session completed. So there is no loss in accuracy, and we have evals for this. Now let me show you another demo. This is for memory. So let's say you start. So there are 3 tabs here. This is the Headroom proxy tab, but there are 2 tabs where I start with Headroom and the 3rd tab where I do not have Headroom. So let's see what happens. I started Headroom with memory. This is the 1st tab in which I'm starting Headroom again. You will notice this is the 2nd tab, and this is the 3rd tab where I have not started with Headroom. Now let's see what happens. On the 1st tab, I say, I want you to remember that I like dark mode. It actually remembered that. Okay. So now go to the 2nd tab. This is where Headroom is still present. I ask, what mode do I prefer? It will say, you prefer dark mode. In the 3rd tab, where there is no Headroom, I'll ask the same question, what mode do I prefer? It will say, I have no information about your preferences. So as you can see, Headroom actually preserved the fact that it was a dark mode, but vanilla Claude Code doesn't remember all these things. And then I said in the first tab, remember that my name is Tejas and I'm the creator of Headroom. So it is trying to remember this. Now I will ask on the second tab where my Headroom is running, do you know my name and what I created? And now let's see what happens. So it remembered. If you saw that, let me go a little bit back. It remembered here. Your name is Tejas and you created Headroom. This is the second tab. This is not the first tab where I saved it. Now, if I go to the third tab and I ask the same thing, it says I have no idea. I can show that again, the last part. It was here somewhere. Oh, this is the, yeah, I think it is this one.
No, it's okay. Go on. That's okay.
Perfect. So yes, this is where it was. Like it did not remember my name. And so this is the production results. We have seen many people use Headroom right now for code search, for debugging, for multi-tool agents. And we've consistently seen around 40 to 80% savings, depending on the type of use case. The best part is there is no information loss because you're preserving information with reversible compression. And why does Headroom win? So you look at the market out there, there is LLM Lingua. This is the basic compressor, text compression. You put in a lot of text, it compresses it. A Headroom actually uses LLM Lingua for some compressors, but it is not good at JSON handling and it is not reversible. Compressor is a Y Combinator funded company. It is so you have to pay for Compressor's API key, whereas Headroom is open source. The other thing is Compressor also does not have reversible compression. I think no one has reversible compression. Mem0 is a Series A funded $24 million funded company that has only memory. They only deal with memory and they do it externally. Headroom actually can compress and deal with memory. And these are the three modes. So we have reversible compression. We have something called as TOIN, which is Tool Output Intelligence Network. The whole idea is whenever the LLM falls back to the original data, because it could not find something in compressed data, we capture those data points and we adjust the compression based on that. So if the LLM is falling back a lot, that means we compressed too much. So next time we will not compress so much. The other thing is it's multi-provider. So it can work with OpenAI, Claude, Gemini, and it has different framework support, works with LangChain, works with Agno. It's growing fast. It's been 10, 12 days since it was released in the open source. It's at 350 plus stars. It's at 370 stars right now. There are around 4,500 downloads. OSS version is free, but we plan to have a cloud version and an enterprise version with reinforcement learning. Right now, we have text. We're working on evals and memory at this point, and we're going to go to multimodal. In fact, images, which is some part of multimodality, we already checked in a code in open source for that. And our belief is that in 18 months or even 12 months, no one sends raw context to an LLM, just like no one sends uncompressed images today. This is the way to start. You can scan this QR code. It will point you to the GitHub repo. Please go ahead, start the repo. Let's partner. Please contribute. Please raise issues. Please feel free to add code as well to that. And reach out to me on email or my Twitter. So
that was cool. Come back to my stream. Yes, and of course, every founder says how cool this stuff is, and it's awesome. It's silver bullet, but of course, there's always some downsides. Yes, and let's talk about kind of what use cases this is not for. I mean, where it doesn't work.
Yeah, that's a fair call. Actually, if you have data that is already compressed, let's say images that are already compressed or data that is already in a small form, let's say Git diffs. Git diffs have very unique data. It is not compressible. So for those, it's not you will not see any savings. You will see 0% or maybe 2%. But for others, you will see a lot of savings. The advantage though, even in those cases, is memory will still work. So even if you don't say any savings when in terms of cost, you can still have memory, and memory will prevent you from sending more context in the future.
Okay, cool. Sounds cool. And what about latency? Of course, it's a middleware, so
yes,
how it slows down the process.
Yes. So the latency is an interesting one because it runs locally on your laptop. So you do not have to have a hop to the cloud for this. For statistical analysis, it is less than 5 milliseconds latency per call. The LLM calls typically take 2 to 3 seconds to return anyway. So let's say you put in something, it'll take at least some time to return. So the 99% of your time is spent in the LLM. So even if this were to take slightly more time, like 5 milliseconds or something, for statistical analysis, it's a very, very small fraction, like negligible fraction.
Especially against that huge saving. Of course.
You can also think about this. If you reduce the number of tokens that you're sending to the LLM, you'll get the inference faster from the LLM. So it can actually save. And I did an experiment yesterday with voice where reducing the like these filler words from voice can actually save up to 10 to 15% in the inference time overall from OpenAI. So there is an added advantage that it can get faster.
All right. And next question is how it actually works. So I understand it removes repeatable parts, right? Or parts that have no significant meaning for LLM. But how can we be sure that it doesn't break the sense and LLM gets the information right?
Yes. So there are two things here. Because we have a reversibility, we track when the LLM cannot make sense of what it got and it has to fall back to the original context. So we capture that. Our goal is less than 10% of the times LLM has to actually fall back. So that is captured and measured. The other thing is we have run evals. So we have run the open source evals like Hotpot QA and others that actually test how sane the responses are, and we have seen 100% accuracy in that. So the F1 score that we saw was 0.95. F1 actually measures the exact match in the output. If we use LLM as a judge to measure the output, then it is around 100%. So so the accuracy is preserved.
Well, the modern LLMs are so smart they can understand it. Okay, cool. So yeah, just one more time, how does this reversible stuff works?
Yeah, so the reversibility works in an interesting way. You compress the data and you store both the compressed version and the original version. And you tell the LLM, this is the data you got, but if you need something more, here is a tool call you can do to get the original back. So when the LLM is looking for a string, let's say ID 47, but it cannot find it in the JSON, it knows that there is more payload sitting somewhere. So I need to call a tool. So the LLM actually intelligently, you've inserted the tool call name. So it will call the tool, and the tool call itself will fetch the data based on the hash from the backend data store, which for now is your local machine with SQLite. And it will fetch that and it will return it to the LLM.
Okay, and how do you prevent the data bloat so it will not explode in my
Nice.
Mac?
Yes. So we have the concept of rolling window or intelligent rolling window. What it does is when we are, increasing the data, we keep on increasing the data. We will try to summarize the older facts of the data. We will use the same compression to compress the older facts as well and roll it off, because the hope is that your 200 k token window is not going to hold everything anyway. So it depends on what kind of information we want to preserve. So we will try to remove older context. Let's say we will try to remove repeated context. We will deduplicate it. And because it is meant to work locally on your machine right now, this context just lives in memory and in SQLite database. So we can, so far we've not run into a situation where it has blown up someone's Mac. But if it does, we can, I think SQLite will just, your Mac will restart and everything will get destroyed anyway.
Yeah. Okay, cool. Well, this tool is quite fresh, right? So it's been some
10 days.
days over there, right? Yeah. And if I can use it in production for my new Geekle platform, which I building right now, how can I kind of rely on that, or I need some fallback? So what happens if it crashes in some reason?
Yeah. So if it crashes, all you have to do is start a new tab with Claude without the proxy, and your life is back to normal.
No. I mean, if I will use it for my app, not for Cloud Code on my
Okay.
Mac.
Yes.
I mean, for my app for the platform.
So there is a fallback mode with 0%, where if you can set the setting, and it will just be a pass through. So it will not do anything in that case. So there is a fallback mode we have.
You have it. You sort it out. Okay, cool. Because it's important for me to know that like it will not crash my app, right?
Yes.
All right, cool. What kind of projects you think will benefit the most of this tool?
I think the ones that have a lot of MCP tool calls and MCP server calls will benefit the most. The ones that read the internet for data, read documents, read code bases like GitHub archive papers. All of those will benefit the most, because as you can see, you send one user prompt, but you will get it's less than like 2 to 3% of the overall token window. And so I think anyone who is working with tools that talk to external databases or data sources will benefit significantly. It can be an app, it can be a agent, it can be a RAG. So all of them show a lot of value there.
Makes sense, man. And yeah, you mentioned about images and sound, like all other formats. But how it works now? What if my chat sends the voice file, and you're not working with that type of files?
Yeah, so we don't actually, we only go and we ignore other multimedia formats that we do not support. So, but we support the ones that we support, we just intercept them. The others is a fall through.
Okay. Well, I like what you do, guys. I like the idea of saving money and tokens, and I do a lot of Cloud Code right now. And yeah, it might be, and the community use lots of these tokens to code. Thank you very much, and yeah, I will definitely try that out.
Yes, and
For myself, I'll do it today, because I'm in the middle of something, and
perfect.
I want to try it. Yeah.
I would love. Yeah.
Yeah, and one more question: how can I measure impact for myself? Yeah. Do you have any monitors or something? Because it would be great if I just connected that, and it would tell me on my browser tab saying, "Hey, you saved $5 just now."
Yes. So right now, I don't, in the open source version, I do not have a UI. I plan to have a UI for it. I just have stats. So if you go to /stats, like I showed, you will see statistics that show you how much money you saved. But there is a fancy UI I can build for it. I just felt like, people that actually use this don't care about UI so much. They care about, money saved. And when the session ends, you will see how much money was saved. So yeah.
Do you mean that Claude command stats, or your internal, or
No.
CLI?
It's actually because it runs as a proxy on a port in your local machine. All you have to do is go to localhost, give the port, and do /stats. So you will see a JSON payload there, which will show you which models were called, how many tokens we saved, how many tokens we sent, how many times we ran into cache hits because of that, and how much money we overall saved. And this is because it's an open source project. My hope is that someone actually in the community can pick up and build a UI for it. Let's say it would be very compelling. I've kept some open areas so that people can contribute. A good example is I have LangChain and Agno as two frameworks that are supported, but someone can pick up Crew AI support and write. The other thing is I have written compressors for JSON, for text, for code. Someone can come and say, you know what, Tejas, there's a better compressor for GitHub repositories that we can use. So they can just plug in the compressor there. Someone can say, there is a better way to work with Cohere models. So they can have that integration. So I've kept open areas for people to contribute in open source, because that's how the community will thrive.
Cool. Yes, and to everyone, hey, people, join Tejas, my old good friend, and help him to actually grow this thing, and let's save some stuff. Thank you very much, and wishing you the best of luck to your new gig.
Thank you, Ed, and it is a pleasure, chatting with you as always. So, thank you, and I would hope that everyone who likes it can star it as well, the repository, so that it gets more like better reach.
Right. Of course. Of course. Thank you. Yeah, and I see you. Yeah, Tejas, hi.
Hi, Ed. How are you?
Yeah, doing great. Thank you for joining. It's still great. How I know you added this monitor, and now people can even track how much they save.
Yes, yes. So there is a dashboard. There's a monitor now. There is support for Bedrock. The Bedrock support so far works seamlessly in the US. Uh, in the EU, there may be some things we need to add for Bedrock support because the endpoints change. So I also recently added Databricks support. So if you have a Databricks account and you're running models on Databricks, you can, and you have like lots of payloads like SQL databases and stuff, you can actually use Headroom there. There are still some quirks left when it comes to, these different APIs, models. So I'm trying to fix this. The hope is that a lot of people try it, they raise issues, and some of them pick it up and fix it actually.
That's cool. Sorry, I wasn't fixing this bedrock problem for myself and had to actually come to you because yeah, I'm not that deep backend developer. Sorry about that. I
No, no,
wasn't
no.
uh,
It's
cause
That's
you
how
any trouble.
exactly. Hmm. Yeah, that's how exactly open source is supposed to be. People will try it out. There will be issues. They will raise issues, and then we will fix. Different people will fix it. That's the power of open source.
Yeah, and how is it going? And by the way, we have Naga. How is it going? Your project right now?
So far it's going good. Like I think I'm getting startups to try it. So there are people that are trying it out. There are people that had legitimate questions around latency and stuff, so they were able to get that answered through dashboard. I think you had the same question, Ed. And dashboard makes it very clear, like what is our overhead versus what is the LLM taking. So it's picking up. I did get a lot of requests for SaaS platforms, which is very good because what people want is, hey, you know what? I have to run it on my machine, and then I switch monitors or switch computers, and I need to run it again. If you have a SaaS platform, we can log in, we can pay some like $40, $50 a month or something and get savings. And I'm like, yes, that's in the works right now. So that's good. We're getting interest from people.
Yeah, I can't wait to try it out myself because I'm the person who ran into the problems with this bedrock, but I hope we'll figure out.
Yeah.
Uh,
I think we'll figure that out. Yeah.
yeah, Naga, thank you very much for coming. We have some questions to you guys, and
Yeah,
let
sure.
me see. Yeah, and what's all? He's not here anyway. We are starting, and first goes to you. Naga, how do you manage granular security when an agent has access to 200 plus containerized tools? For Tajas, we're talking about Docker AI platform.
Yeah, so that's an advantage, right? Like without Docker, MCP gateway and toolkit, now you have to manually manage all this 200 plus tools. And imagine you're moving between one application to another application. So if you're starting again a new agentic AI application, you have to deal with it again, the authentication, managing and everything. So with Docker MCP, now you do it only at one time in one place. You just go to the Docker desktop and you would do it there. And once you added all the credential management and everything, and just to make sure everybody is understanding this particular security thing, the Docker MCP image that you get is 100% reliable and 100% secure. So you can easily don't need to worry anything about security as compared to picking any MCP server directly from the internet. So that's an
Okay.
advantage. You get it automatically. And once you do it in the one place, now you can just plug and play in multiple applications. It's just 4 lines of a JSON file or 4 lines of YAML code that you need to add into your application, and you get all the 200 servers in under your control.
Yeah, so probably the answer, don't add any crap there, right?
Yeah.
Yeah, thank you very much. And going to our next question goes to you, Tajes. How does Headroom handle race conditions when multiple sub agents try to access the same memory simultaneously?
Yes, that's a good question. Actually, we have reader-writer locks implemented on the SQLite database. So earlier we had in-memory graph and vector when it runs locally, but then we realized that as people are getting more memory, we are running into space issues on the machine. So we then started persisting it, and we have locking, so that prevents race conditions from impacting the memory. However, note that the way open source is currently, it works on one machine. We do not claim that it is scalable to multiple users that have memory that can overlap with each other. The hope is that open source is good enough for a lot of people. For folks that have more sub agents that require deeper memory support, I would love to have a chat with you, like how you imagine this going, so that these are features we can add to our cloud variant, like the Headroom Cloud that we plan, which will be a managed offering with logins, with SSO, with audits, with memory, all of that. So it will be per organization for multiple subagents and give you statistics of memory and stuff. So I would love to have conversations if there are folks here that want to do that.
Okay, okay. If I'll hear back from someone, I will definitely connect you. Yeah, and let's move on. What happens in your infrastructure costs when autonomous agents get stuck in reasoning loops? Man, that's
Yeah, so basically, like when agent getting stuck in reasoning loops, right? So I think you need to understand what particular question that you're asking and the context that you're providing to the agent. So most of the times when during the development cycle, like I've been playing with a lot of agentic AI applications, so I did face this issue, and I should definitely tell you that I ran up all my credits as well. So when I was creating this agentic AI application at MCP local server to do some stuff, and by the time when I reached to a certain stage, I already exhausted all my credits. So there is definitely infrastructure cost related to it, because what I was trying to do is I was trying to host this as part of Azure Container Apps and on the Azure, so that everybody else can use it. And yeah, I ended up exhausting it. So even I don't know, like what exactly we would be doing when we are dealing with this reasoning loop. But what I did was, once I got my credits back, once I increased my credits, I went back and I again used AI to ask questions like what was happening behind the scenes, why was AI stuck in that particular loop, and then it gave me some really good answers. And I use the agent mode, so that's where you can leverage the GitHub Copilot. So the agent AI itself, it just modified bunch of code in my current application. And after that, I was able to run it. So I
right.
seriously don't know what exactly happened there, why it went in the loop. But yeah, this is one thing that the most of the developers are facing when they're building your application.
Right, guys, it's 2026. If you let your agent stuck and actually burn thousands of dollars, it's question not to Docker, probably, right? Probably it's question to you.
Yeah.
All right, let's go. So next one, does the reversible compression feature create a latency bottleneck during high frequency tool usage?
Good question. The hope is that 80 to 90% of the times you would not use reversible compression. The hope is you will get what you're looking for in the compressed data. The remaining 10% of the times is when you will have a fallback. Currently, the way it works is it's in memory with a TTL of 5 minutes. So what happens is, if your agent is requires some data, and the tokens that were returned to the LLM did not have that data, the LLM will call a tool that will fetch it from memory. And it is just 1 to 2 milliseconds latency at this point when it comes to fallbacks. The hope is that it doesn't happen many number of times, and when it does happen, we track whenever the LLM is falling back to reversible compression, and we make sure that the next time we compress the data, we understand from that and don't compress these things out. So there is a natural learning over time that will help reduce reversibility access as much as possible.
Okay, it sounds really smart. Okay, so how do you debug an autonomous workflow when you can see inside containerized reasoning? You can't see inside the
Yeah,
reasoning.
yeah, definitely you can't see, but once you enable the logs, right, so you can read what exactly the AI is doing. So when you run, like let's take an example of Visual Studio or Visual Studio Code, and you're leveraging GitHub Copilot in it, right? So there are this multiple different options that are available, like ask mode, agent mode. And once you go into the agent mode, you can also, spit out all the reasoning that LLM is doing. Like you selected different models, right? Now you can get more logs. Once you enable that particular switch, it will give you what exactly LLM is doing. Like it gives you all the minute details about how it is planning, how it is creating the next steps to follow. So, and you can also dump this into an MD file at the end if you want. And then you can take a look at, like, what is the reason behind LLM thinking in this way? Is it because of your prompt, or is it because of some other additional steps that you have provided in the skills.md file? So it completely depends on you, as you are the one who is driving this, right? So based on your prompt and based on the context that you're giving to the LLM, then only it's able to perform an operation. So if you want to see it, definitely inside the LLM, what's happening you can't see, but how LLM is responding, that you can easily dump from any of the tools. Like most of the IDEs provide that information right now. So I've been using and playing with GitHub Copilot, and I've written this in my latest book as well, how you can go and dig deeper and get information about LLM reasoning.
Thank you very much. And moving on, the next one is the local SQLite database a potential target for prompt injection? Wow, or data thief?
Yes. So the local SQLite database contains only memories, and it does not contain any of your prompts or any of the responses from tools. It lives. SQLite is a persistent storage. When we are getting tokens back from any tools, before we pass it to the LLM, we keep it in memory for 5 minutes, and then we are TTLing it out. So your local SQLite database only holds your memories. That is, if you like dark mode or you don't like dark mode, there is that window where your SQLite database can be accessed. But because it's a local system, because you're using sending prompts to OpenAI and Claude and other LLMs, they do not have access to your local SQLite database. So you will not run into a scenario where an LLM is trying to interact with your local system. If we had a cloud version, we would ensure that it is encrypted at rest and in motion. So you will not have those situations. The open source version, it does not have those like threat metrics.
Okay, so can they inject some, I don't know, code that will be stored in my data, and then it will harm me or something?
So the hope is that when you are getting the LLM responses, or rather your tool responses back, at that point, your LLM, like we have LLM Lingua and other compressors, they will compress out your response from a tool, and then they'll send it to an LLM. It will store the backup copy in memory. The LLM itself, will not allow any tool calls unless we have provided it to read from your local memory or your local SQLite. So that is one factor that prevents any such prompt injection attacks. The other thing is, if you are working with a local SQLite, I think maybe this is a great issue to look at for the open source community. If we can have encryption turned on in SQLite. Right now it's basic SQLite, we just it runs on your laptop, but we can have a lot more things there in the open source where we have access control, RBAC, ABACs to local database. These are table stakes for a cloud version, not so much for a local version.
Okay, cool. Yeah, I mean, yeah, if you want to use it for cloud code, you're okay then. But if you want to use in production, user facing apps,
exactly,
just go to this open source repo and fix this problem, and there will no problem anymore.
Yes.
And the last one goes back to you again. Does the cache aligner actually increase cost for every short unique session?
Actually, no, it does not. The whole idea of a cache aligner is it'll take, you're sending a prompt to an LLM. OpenAI and Claude say that if the prompt is with the same as the older prompt that you sent, we will give you a prefix cache hit. So we will charge you only 10% for this new prompt. Now, the problem is many a times in a given prompt, there are some things that change. Let's say the date has changed, but everything else remains the same. Or the UUID has changed, but everything else remains the same. Without using Headroom, you will not get the cache hit on OpenAI or Claude. But if you use Headroom, Headroom looks at your prompt, takes out these dynamic pieces out, puts it at the end of the prompt, and then sends the prompt. So it will divide the prompt into two parts. There'll be a static side and there'll be a dynamic side. The hope is that the static side will still run into a cache hit. So you will not have a fallback that you're paying more for short unique ones. If there are short and unique ones, you're paying whatever you were paying anyway to OpenAI and Claude. There is no benefit, but there is definitely no loss with cache aligner.
Okay, cool. I like it. And the last question of today's session, how does the system handle the performance lag between switching between local and cloud inference?
Yeah. So actually, I wanted to also include a topic called Docker Model Runner. So people are interested, definitely check this out. So what it does is today the models, right? So there are if you go and look at Hugging Face, you can see different models available there, or even the GitHub models as well. So all the models are close to 1 GBs to some hundreds of GBs as well. If you look at any Quen Alibaba models. So what Docker Model Runner does is it will automatically pull that model into your local. So you can download that model within your Docker desktop, and you can run and plug and play with this local models, running it locally on your machine. And then, not every machine will be that powerful to run this models, right? So you end up having more GPUs on your machine, or it needs to be a beefier machine. So what Docker has done is they also introduced another feature called Docker Offload. So what it does is you can basically run your particular workload or operation in the cloud. So you need to enable a switch, and it automatically. So what they have done is they didn't make any change to the underlying commands, or how you currently operate today on Docker running locally or on cloud. It's just a matter of changing the button or running one command, Docker offload, and automatically the Docker, they are providing you with NVIDIA G4 chips where you can directly run your workload on that particular machine. So when you talk about the local as well as cloud, if you have money, you can run it. Definitely, you can get a beefier machine and run it locally. Or if you want to use use subscription, you can leverage Docker offload and you can run high intensive operations on cloud as well. So that's what I've been playing with. Since I'm a Docker captain, I got some free credits for leveraging the Docker offload as well. But if you are trying to get it as a free user, I think by default they provide you with some 500 credits by default. And once you run out of it, then it's pay per use subscription model. So definitely check out the Docker offload feature as well. So it makes it easy for you to run heavy intensive operations on the cloud without doing anything. You don't have to manage the machine. You don't have to run different commands just to run on the cloud side. It's still everything the same, but Docker does it on behalf of you. I think you're on mute. Yeah.
Yeah, I was saying some kind words to wrap up. Thank you very much for coming here and sharing this interesting tech with us. Thank you, Tajas. Thank you, Naga. I hope you are connected both on LinkedIn. If not, I'm recommending you, because like you guys are in very similar space, and I'm sure you'll have something to chat about. And for others in our audience, guys, please go ahead, go on our website. Let me pull it even off, or no, I'll not do that. Just go on our website, find these guys and follow them and ask them questions, and help Tejas to build this optimization stuff that will save lots of money for us. Thank you very much, Tejas. Thank you, Naga.
Thank you.
Yeah.
All right. See you maybe next time on next event or chapter. Have a nice day, guys.
Thank you. You too.
Yeah. Bye-bye.
Bye.
So yeah, that's this is it. We just finished our chapter, and this was the third one. And I can't wait for you to see you on the next one. Have a nice day, evening, whatever you have. If you need some group discounts or corporate invoices or whatever, just hit me over here. Where is it? Over here. Yeah, events at geekle.us. Or also, if you can't afford our pricing, you can always write to this email and explain your situation. We have scholarship, we have national discounts, so don't worry, we will get you covered. We need you to learn and grow with community. Thank you very much for being with us, and see you on the next one. Bye.